Okay, so number 5 says draw and recognize resonance structures. So if you have CO3 minus 2, I've got 4 electrons, 3 times 6 electrons. Does the minus 2 mean add or take away electrons? Add, because electrons are negative. So I gain 2 electrons somewhere. So that means I have a total of 24 electrons. So if I put carbon in the middle and attach each one with a single bond, each oxygen would still need 6, and carbon would still need 1 pair. If you count that up, how many electrons is it? It's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It's 26. So the 2 electrons is telling us you need a double bond. Does it matter which oxygen gets the double bond? No. So I'm going to go ahead. Well, I'll put it here. So then that lone pair comes off, and that lone pair comes off. My C and O back together. So that's what it would look like, but because we said it doesn't matter where it goes, what that means is that there's more than one place it could go. That's resonance. Resonate means like to vibrate or move among, kind of move in the same place. So it could just as easily be this way. And yeah, you really do have to draw the lone pair in. It's the only way you account for all the electrons, that you actually know what you're doing and you didn't just get lucky. And it could also be with it down there. The reality is this double bond rotates between all 3 oxygen. It resonates or moves among all 3 spots. So that's resonance, is when you have a double bond that you could just as easily draw more than one spot. Yeah. I don't care if you do, if you know what that is. If you read the book, you know what that is. I'm fine with that. If Miss Fleece counts it wrong, tell her I told you at the study session it was okay. How's that? So yeah, a few people have drawn the resonance structure. I'm fine with that. But then make sure you get your lone pair in. You still need the lone pairs with that. So when and why does resonance occur? It occurs when a double bond can be placed in more than one spot on a molecule. And just remember, between the same 2 kind of atoms. Anybody know why it occurs? Why that double bond rotates? I just mentioned on the last one with SiO2. Why does SiO2 form 2 double bonds instead of a triple and a single? It's about balance. It's the same thing. If you had 1 double bond and 2 single bonds, you've got 1 short bond and 2 longer bonds, so that 1 oxygen moves closer. That takes things out of balance. Even though it's 3 oxygen, it changes things up. So instead, it rotates among them. It keeps the molecule more balanced, and that equals less energy needed. Compounds are all about stability or balance. Stable means it takes less energy. Nature behaves just like us, or maybe it's we behave like nature. Nature does what takes the least amount of energy. It's just the natural order of things. So then the last part for number 6 is I want to contrast our CO3 minus 2 with CH2O that we drew back for number 4. So I'm going to pause and put both structures here. Okay, so the reason I wanted to look at both structures from example 4 and 5, or from objective 4 and 5, is do you see why CO3 has resonance versus CH2O does not have resonance?
Please call extension 88066. Please call 88066.
So don't, now with hydrogen, you're probably less tempted to try and move the double bond, but if that had been 2 sulfur with oxygen, some people would go ahead and move it, and it's not going to. And how would you know the oxygen, or that the double bond would form with the oxygen rather than with one of the sulfur? Because again, it's about balance. If both sulfurs can't form a double bond, then it would probably bond with the oxygen. Does that make sense? You're not going to get anything that tricky on the test, but it's always going with, the other thing that would help determine is electronegativity, which that's more particular than we're going to get into. But like if it had been fluorine there, you maybe would have been tempted to move the double bond around to the 2 fluorines, but it's not going to happen. It has to be moving among the same 2 kinds of atoms. So an example of resonance and no resonance.